Let's go to VCO 397 integer replacement. So for this integer n, we want to return the minimal number of operation needed to become 1. So if n is even, replace n with n divided by 2. If it is odd, we can either add 1 or minus 1. So we know the first op so this one we can also do so we know that n divided by 2 is the optimal operation. So if we don't have if, right, we still should go try the first operation first. But it just let us say if it is even, then divide by 2. If it is odd, then plus 1 or divide minus 1. Here, we can still use a while loop or for the question, but need some improvement so that if this is even divided by 2 and odd, there are two cases that n equals 3 or the bit counts if add 1 is greater than bit counts minus 1. Then we um, minus 1, otherwise plus 1. But this one, this kind of mathematics sometimes is prone to get errors. So the more general way for this kind of question, we just don't need to think too much to use mathematical proven. Just write a DFS and a memo for this question. So we can so we need a map for the memorizations. So let's write code. Private long DFS. So we'll see long number array, right? So we need a hash map long long. Um, whether it is possible, we goes too long out of the range. It's possible, right? Because n is can be integer max, and if we add 1, it may alter the bound. So let's use long and never. So what we do is that if I equals 1, right, just return 0, and if memo contains key I. Let's change this to be I. Just return memo get right. Otherwise, let's have a long result equal to 0. So the thing is that let's say if I mod 2 equal to 0, right? This is deterministic result equals DFS I divide by 2 memo plus 1. Else you need to find which one is smaller, right? Result equals mass of mean DFS. We have options I plus 1 memo, right? And DFS I minus 1 memo. And we have one operation, right? So in the end, we just memo put I result return result. Our main function just return int DFS 1L multiplied by a new hash map long long. Uh, the time complexity, we'll see the divide will be the main operations, right? So for add, when we add, if this number is an odd, right? It will of course go to uh even. So we'll see the even number will operation this divide operation will take about half of the operation numbers, right? So we'll see the operation is still a log V operation. Um, in the space, right? It will be O and O log. It's still a log because we will not store that many, just log number of the values, right? And also this DFS is also a log of a space. Um, then our Python code. So memo equals this, and df, DFS, right? And to for this question, if we don't have memo here, you can also write a hash, right? Like this. Um, and if I equals 1, return 0. If I mod 2 equals 0, result equals DFS I divided by 2 plus 1, right? Else, uh, result equals mean DFS I plus 1, GFS I minus 1 plus 1, right? And the return result. In our main, we just return DFS A, right? Uh, of course, well, we don't need, actually, this question don't need a DFS and a memo. We can still use a while loop to write it, but we need to know when I equals 3 or I mod 4 equals to 1, right? On these two cases, we use um, we use -1 operation. Otherwise, use +1 operation. But we need a mathematical proof this concept.